Okay, this is our next pre-AP video. We're talking about refraction. I think you know what refraction is, but just in case, this is an example. I have a glass of water here. It has a pencil in it. You can see right here in the water, you see the pencil being magnified, and it looks kind of broken from where it is here. You're seeing through the glass where it's a little bit different. And then up here, through the air, it even looks different than it does in the glass. The diameter looks a little bit different, and then, of course, it's a little bit more hazy through the glass as well. But the change in what you're seeing as far as appearance is due to light bending. It's a refraction of light. And the reason that happens is because the speed of light changes as it goes through other mediums. We use the speed of light as a constant, and we say that constant is about 300 million meters per second. Okay? But what's going on is that light, whenever it hits something more dense than the air it's traveling through, and this is the speed of it in a vacuum, when it's traveling through air it's a little bit different, and when it's traveling through something else that's transparent, it's even more different than that. So just as an example, if you can kind of think about this ruler as being something else, like glass or something, or water, something like that, whenever light comes, it's traveling as a wave, but that wave has these little wavelets, little bitty wave fronts like this. And when they hit, they're going to hit just like if you've ever run from a beach into water. Whenever you hit the water, your feet are going to slow down and your body kind of wants to move forward, so you begin to kind of fall forward. That's what's happening with the waves, with the light wave. Another example, say these wheels are like part of a wagon or something, and say this ruler is sand and this is concrete and this is concrete down here. If these wheels were to hit the sand, then the wheel that hits the sand first is going to go slower than the wheel on concrete and kind of naturally make it curve a little bit. Okay? When they come out, this wheel down here is going to come out first. It's going to speed back up and come back across. And so what happens is it slows and bends and then speeds back up as it comes back out. They're both traveling across the same material, they're going in a straight line. So you have it kind of come at an angle, bend down, and then come back out at the same angle it was to start. That's refraction. That's what light's doing, is it comes, it hits into a different medium and bends. So those waves, as they travel, the light comes through, hits the material, slows down, speeds back up at its original angle. And so that angle's the same as that. And then this is greater. That's assuming that this substance is more dense than that, which gives it a slower speed. Okay? We're going to talk a little bit about what different materials have different speeds and stuff like that, just in kind of the behavior. We're not going to get into a lot of specifics on materials, but we're going to talk a little bit about why that happens. And part of that, we use something called Snell's law. Snell's law says this. It says that the angle of incidence, or the index of refraction, the index of refraction is equal to the speed of light over, and this is speed of light in a vacuum, over the speed of light in the substance, or better known as the medium. Okay? And that little value right there, that index of refraction, is what's used in order to figure out what's happening with the material. Okay, this is how much a material will bend the light. Okay. Now, Snell's law itself says this. It says that index of refraction for the incidental material times the sine of the incidental angle is equal to the index of refraction for the second material, for the refracted material, times sine of the refracted angle. So refracted angle, incidental material, refracted material. So this would be basically the first material that's coming from. This is the material it's going into. Okay? Alright, now here's kind of how that comes into play. What happens is whenever light hits something, it bends, okay? And it's going to, I'm going to give you the idea of how it bends. Now, say we've got somebody fishing here. We'll call this person maybe Duncan. And let's say Duncan likes to fish. So, but Duncan's not just an ordinary fisherman. Duncan likes to spearfish. So Duncan's going to get out here and spearfish and try to get that fish. Now, where should he aim to get the fish? See, what we have to remember is our brains expect light to travel in a straight line. So Duncan's looking about right here, and he's having light come from that fish like this up here to his eyes. So he's expecting to see this fish right about here. He's expecting this fish up here. That's what he thinks is happening. This is where his brain perceives it. He's saying, a delicious bass, right? So he's going to bring home a delicious bass for supper. But if he aims for what he's seeing, he's going to miss the fish, because what's really happening is the light, when it's coming from the fish to Duncan, is coming right up this way. In fact, I'm just going to solidify that line to show that this is the actual ray in the direction it's happening. What happens is as light's coming from the fish, it hits this less dense material. See, the water's more dense, the air's less dense, and it bends away from normal. Remember, that perpendicular line we call normal, and so it's bending away. Okay? Alright, now from the fish's perspective, it's just kind of the opposite. The fish sees Duncan. And when the fish sees Duncan, the fish is saying, oh no. You know, and fish are stupid, right? So they really don't know what's going on. But what's happening is that light's coming to the fish like this. And again, brains expect light to travel in a straight line. So the fish thinks that Duncan is up here. That's where the fish sees Duncan. In reality, Duncan is back here, sitting on the dock ready to spear the fish. Hopefully he learned the lesson and knows the fish is down here and not up there. But the fish sees him up here. So he's going to get scared because he thinks he's closer. Because what happens is, as it's going from a less dense material into the more dense, the light bends toward normal. it's coming in toward normal. So as it goes to more dense, it's going to bend towards normal. And again, that's because when it hits, it slows down and bends this way. It just kind of catches an edge. Okay? All right. Another phenomenon that happens with this is called total internal reflection. Okay? With total internal reflection, the thing about that is that if you have a material where the index of refraction is greater for the incidental material than it is the refracted material. Example, you're going from water into air. Okay, like this one, water into air. Okay, if you're going from water into air, what happens is that the light at certain angles, if you get that angle down low enough, it's not even going to make it into the other material. It's simply going to reflect inside itself and not come out. Again, total internal reflection. And the way you figure that out is you take sine of the angle, and this is called, basically this angle, the value that happens is called critical angle, okay? Sine of the critical angle is going to be equal to the index of refraction for this secondary material divided by the primary material, okay, or the incidental material. If that material, if the incidental material has a greater index than secondary, then this is possible. Okay? Alright, and again, by the way, that angle would be equal. Okay, here's the last thing we're going to talk about with this. We're going to talk about mirage. And mirage is actually a real phenomenon, okay? And what happens is as the light, for example, if you're driving this summer on a highway in the heat, you've got heat coming up off the highway. What happens is up here in this material, where the air is a little more dense and it's happening like you expect, everything is happening like you expect it to, light will travel in that straight line you see. But remember, light's traveling in all different directions, being reflected in all different directions. And so what also happens is the light is going to travel this way, but whenever it's coming down here, this material is less dense than that. Okay, so this secondary material has a less density than the primary, and you can get this internal reflection. And so you have another set of rays coming up like this that you see while you're driving down the road. And your brain expects light to travel in a straight line. So what you see is a reflection of what's down here, out here in the middle of the road. And usually what that looks like is sky. You usually see what you think is a puddle out here in the middle of the road, and what you're seeing is a reflection of the sky. You just don't realize that that's what it is. And that's a mirage. Because of a total internal reflection, less dense air, more dense air, the light bends, and you see the same thing, but you expected it to be in a straight line. Okay? Alright, we'll call that good on refraction. We'll talk about lenses in another video, thin lenses and what to expect with that. We'll talk about converging lenses, and we'll talk about diverging lenses, probably in 2 different videos. Thanks.